What up, everyone? What's up? How you all doing? Let's check something. All right, so today we're looking at singular matrix, and what a singular matrix is basically after you find the product of the leading diagonal minus the product of the second diagonal, if the answer is 0, is said to be a singular matrix. So let us just remember that every matrix is in the form A, B, C, and D, right? So we can just say determinant. Let's put DET, what I write, all right, now what the problem marks. So if you like formula, this is the formula. So it's a leading diagonal. So it's A minus B, right? So all we're doing is multiplying 2 times and more 2 times A. A times D, in this case it's 2 times the 6, and B times C. So let us do that. So A times D would be 2 or 6, or D is 6, so times it by that. Minus 3 times 4, which is BC, right? If this answer works out to 0, then it is said to be a singular matrix. All right, so let us work it out. So 2 6s, 12 minus 3 times 4, that is also 12. And 12 minus 12 is 0. So therefore, this matrix, let us call it matrix A, this 2 by 2 matrix is said to be a singular matrix. Once the determinant is 0, it is said to be a singular matrix. And if it's not singular, it is said to be non-singular. All right? All right, guys. So what I want you guys to do now is to tell me or try, work it out. I'm going to give you guys a minute and see if you guys can tell me if this is a singular or non-singular matrix. All right. So I'm going to give you guys 1 minute. I'm going to give you guys 1 minute. Oh, this Well, go on. They are recording on video. They are recording on video. Good. Yeah, matrices. So when you mash up already. Yeah, man, you come every day. All right. You know you have to take it over. All right, thanks. Yeah, all right. So that peeps, I'm past you and that, you know, you're the 1 in a maths. Yeah. It's because I'm recording. I mean, just this video. That's why. All right, everyone should finish that by now. But remember, we say what a singular matrix is. A singular matrix is when the determinant is equal to 0. So let us just see if we'll work it out if we're gonna get 0. So it's A times D, right? And C times D opposite. This is actually C, right? Yes. So it's A, B, C, D. So we're going to multiply A times D. It's very simple. Minus B times C. If the hand size is 0, then it is said to be a singular matrix. If not, it is non-singular. So let's go. A is 3, so that's 3. D is 2, so multiply it by 2. Minus 6, and this always mess up students. 6 times negative 1. What you can do, guys, is to put this in bracket, alright? So you can see the question clearly. Alright, so let's go work out the bracket first, and then you can proceed. So 3 times 2, that is 6, minus 6 times negative 1, and negative 6 times negative 1, and a positive times a negative will give us negative 6. Alright, so now these two subtraction is going to give us a negative times a negative. It's going to give us a positive. So it's 6 plus 6. So that is equal to 12. So therefore, it is said to be a non-singular. Not singular, but non-singular. Alright, guys. I want to leave one with you guys for homework, and you guys leave it in the comment section. Alright, guys, so this is the one that I want you guys to try. You can try it now, and if you have enough time, and see if it is a singular or non-singular. And remember what we say a singular matrix is. A singular matrix is when the determinant is equal to 0 and somewhere Mr. My Takers, she don't believe it's a better. You're going to hear it in the video. Alright? So a non-singular is when the determinant is not 0, while a singular is when it is equal to 0. Alright? This is Mr. Bennett. I'm out, no doubt. Thank you guys for watching. One thing in a piece. One thing.